Hi, today we are looking at section 9.2. So this is our second part of our constructions. So for these, once again, you need a geometry set because we will be drawing arcs, circles, straight lines. So today we're focusing on constructing polygons. Last lesson, we focused on perpendicular bisectors and angle bisectors. We'll use our perpendicular bisectors in some of these constructing polygons. And once again, we'll start by some simpler shapes and work to more complex. So we'll start with constructing an equilateral triangle. So to construct an equilateral triangle, our first step will be to draw a line segment. We then will set our compass for length of the line segment and draw arcs centered on each end of a line segment. Now, I don't have the ability to just draw an arc on here, so I'll be drawing full circles. Now, once we have our arcs drawn or centered on each end of our line segment, we're going to draw lines from each end of the line segment to where our arcs intersect. Okay, so we'll start by drawing our line segment. Okay, so there's our line segment. What we'll do after that is draw a circle that's centered on one end and goes to the other end. What we'll do next is start the other end and go to the first end. Now to draw out our equilateral triangle, we'll then go from the end of our line segment to where these intersect, and from this end to where they intersect. And theoretically, this should produce an equilateral triangle, so therefore all three side lengths should be the same, and all three angles should be 60 degrees. Next, we have constructing a square. So to construct a square, we'll start with a line segment AB. Now, I've just called it AB. You can call it whatever you want. We're going to then create a perpendicular bisector to AB. So if you remember from last section notes, to create a perpendicular bisector, we'll create arcs or circles centered on each end. They have to have the same radius, and where they intersect, we'll draw a straight line to get our perpendicular bisector. Okay, so where these intersect, we'll draw a straight line. Okay, so now that we've got that, our next step is use the midpoint of AP, which we now have because we have our perpendicular bisector. So we'll start the center there and draw a circle that is the same length or has the same radius as those distances. So you can see we've got the circle that goes from here to here. And then what we're going to do is create our square by going from where our circle meets our original line segment to where the circle meets our perpendicular bisector, to where it goes back to our line segment, to where it meets our perpendicular bisector, and then back to our line segment. So theoretically, if we have done this accurately, we should have a square with 4 equal sides, and each angle should be 90 degrees. Okay, so these two shapes are amongst the simpler of what we'll be looking at today. Next, we have constructing a hexagon. To construct a hexagon, we'll start by constructing a circle. We'll then choose any point on the circle and draw another circle of the same radius. Where it intersects the original circle, we will draw another circle. We'll repeat that till we've drawn 7 circles total, our center one and 6 others. Then we're going to join common intersection points with straight lines. So just to help me out, I'm going to mark where the center of my first circle will be. Because I'm going to need that for making sure my radiuses are the same. But if you're using a geometry set, you shouldn't need to do that. So I'll start with one circle. Then I can choose anywhere along the edge of a circle and start a new circle. And has to have the same radius as the original. So that's why I marked the center of the original so I can see that I've got the same radius. We'll then find one of the places where it intersects the original circle, start another circle with once again the same radius. We'll find where this one, where this one intersects, and once again do the same thing. Find where this one intersects, do the same thing. Where this one intersects, and lastly where this one intersects. So we have now drawn 7 circles. We've got 1, 2, 3, 4, 5, 6, and the center one. What we'll do next is find these points where we have essentially 3 circles intersecting each other and just join them. And if we have done this correctly, we should have a hexagon where we have 6 equal side lengths and all the interior angles should be the same. Now the flower shape created is often used in art and architecture. 19 of the flower shapes together is referred to as a flower of life. So that's referring to this part here, where we've got essentially these little flower petals. If you have 19 of those, that's referred to as your flower of life. Okay, so next step is constructing an octagon. What we want to do is draw a line segment, then construct its perpendicular bisector. Then we're going to create a circle centered at the midpoint that reaches the end of the line segment. So just like we would when creating a square, we're going to draw 4 identical circles centered where the previous circle intersects the line segment and the perpendicular bisector. We'll then draw a square using the middle circle and mark where the outer circles intersect the square and use these points to create an octagon. Okay, so we're going to start with our line segment. We'll then create our perpendicular bisector. I've got my 2 circles for creating my perpendicular bisector. We're now going to create a circle that's centered at this midpoint like we would if we were doing a square. Now we're going to draw 4 identical circles centered from where our original line intersects a circle as well as where our perpendicular bisector intersects that circle. Now typically we'll do them with the same radius as the radius of the circle we just drew. We're then going to draw a square using our middle circle. So for a square, we're going from here to here, to here, to here, to here. Now to create our octagon, we are going to go from where we have got 2 circles intersecting part of our square to another place where 2 circles intersect our square. So from here to here, from here to here, from here to here, and from here to here, and then we'll join those line segments. And we now have our octagon.